Hello, my name is Kalen Rasmussen, and I am presenting on the influence of anaerobic oxidation of methane on the precipitation of seep carbonates. Let's dive in with a brief background of methane seeps. On the top, you can see the sulfate-methane transition zone in methane hydrate sea sediments, where the syntrophic relationship between anaerobic methanotrophic archaea and sulfate-reducing bacteria occurs. On the bottom, you can see the individual and the overall metabolisms. Please note the production of bicarbonate, which fuels precipitation of carbonate. For this study, we chose to examine the ancient methane seep carbonates located in the Panoche Hills, California. Two of the research questions I will discuss today are, what are the differences and similarities of methane seeps, and what do they tell us about geological time? Additionally, do methane seeps record evidence of anaerobic oxidation of methane? To begin, we developed a petrographic framework. For clarity, we have defined our interpretation of micrite and spar for this analysis. Displayed are representative images of the classified fabrics with the associated classification to the right of the image. Micrite 1 and 2 are small quartz grains surrounded by homogeneous micrite, but differ in texture. Additional types of spar were observed. From these results, we were able to develop a paragenetic sequence that was similar to other carbonate sequences in the literature. The next component of this work was to examine seep carbonate isotope geochemistry. The figure shows the isotope geochemistry of oxygen on the x-axis and carbon on the y-axis with respect to the VPDV standard. The blue box on the graph shows the carbon and oxygen isotope signatures of non-seep paleogene carbonates. The majority of samples compositions land outside of this box. The oxygen isotope signatures exhibit a narrow range and fall within normal values of marine carbonates. The delta C13 values will vary widely, suggesting mixed sources of carbon. Next, I would like to discuss some of the biosignature results via lipids analysis determined by mass spectrometry. Lipids synthesized by microorganisms may be entrained in the seep carbonates, preserved and altered over time. Lipids commonly associated with methanotrophic microorganisms, such as crocetane and squalane, were found in our samples. Lastly, the delta C13 value associated with this sample was -33 per mil, which lies within the range of values associated with AOM processes. So, in conclusion, the paragenetic sequences observed were consistent with those found in the literature of methane seep carbonates. The isotope geochemistry of the micrite suggested multiple sources of dissolved inorganic carbon, and we were able to find multiple lipid biomarkers that are associated with anaerobic oxidation of methane. So I would like to thank you for your attention today, and I would like to thank the International Geobiology course for the opportunity to work on this project, specifically my co-investigators Danielle Asario Rodriguez, Anais Russell, Camila Arias, Michaela Ingalls, and Russell Shapiro.